In this second video on logs, we're going to have a look at the rules of logs. Now, basic rule of thumb when we're looking at these is that the rules of logs are the opposite of the rules of indices. Yeah? For example, okay, well, that's the first one we did. That's the sort of definition of a log there, isn't it? Okay? But if we look at the second one, you know how x stands for x to the power 1. Okay, well, log to the base a of a is just 1. That's like the opposite of that one. Similarly, you know how anything to the power 0 is 1. Well, log to any base of 1 is just 0. This one, yeah? You know when, if I had x power 1 to the power b, we would multiply those to give me x to the power b, wouldn't we? Well, it's the other way round here, yes? When it's a power on the inside, so b there, it becomes a multiple here. So it's b times the log of a to the power x. So whereas when you're raising to a power, you are multiplying with indices. Here, when it is raised to a power, you are multiplying the log. Okay? So that becomes that one. A little rule, if they write log, they really mean log to the base 10. If you look on your calculator, you'll see there's log written there. That is sort of log to the base 10. We'll do more on that later, but if they say log, they mean log to the base 10. There is one other sort of special base that we'll look at as well later, but that's getting beyond the point. So if they say log, it's log to the base 10. You know, with indices, when we multiply, we add. So with logs, when you add, you multiply. Yeah? You know how a to the power x times a to the power y would be a to the power x plus y, wouldn't it? Well, it's the other way round with logs, okay? So when you add logs, you multiply inside, okay? Provided they are to the same base, that's very important. Similarly here, when you subtract, you divide. Well, we knew that, didn't we? Because, you know, a to the power x over a to the power y would be a to the power x minus y. Well, it's the other way round. So when you subtract logs, you divide. But again, remember, it's got to be when they're at the same base. Okay, what we're going to do next is we're going to look at using these rules I've written down here for you with a few examples. Okay, that's the next thing we're going to do. I've put the rules down the side here so you can see them. Okay, if we look at the first example there, remember these are all logs to the same base. They're all to the base 5, which is fine. So if I looked at this first one here, remember when we add, we multiply, and when we subtract, we divide. So that's really log to the base 5 of 10 times 10 over 4, isn't it? Yeah? Which is log to the base 5 of 100 divided by 4, which is 25, isn't it? But, you know, log to the base 5 of 25, you know 25 is a power of 5, isn't it? So I can write that as 5 squared, because 25 is 5 squared. And then if we're using this one, it's just going to be 2, isn't it? Yeah, the log to the base 5 and 5 to the power cancels out, giving us just the 2. Okay, so that would be that example there. Remember, when we added, we multiplied. When we subtracted, we divide. And if we can write it as a power of the base of the log, then they cancel each other out and we're just left with the index. Okay, let's have a look at the next bit. Two ways we could do this one. It's quite a short one, really. Remember, log, I said, is really log to the base 10. That's not really relevant here because this would work for log to any base. Okay, so we know, I'll do it this way, look, 4 log of x minus, now look, x to the power 4, we know when it's a power, we can write it as multiplied. So that is the same as 4 log of x. And 4 log x, take away 4 log x, is nothing. Okay, so that's just first 2 examples. I'll go through 2 more examples next. Okay, a couple of more complicated examples here, but it's the same idea. First of all, remember when you add, you multiply. So that's what we've got here. Now, if you remember, if we raise both sides, like this, to a base of 4, yeah? So we've done the same thing to both sides. Remember, 4 and log to the base 4 cancel each other out, so we will just be left with x minus 1, x plus 2, and 4 to the power 1 equals 4. Okay, remember we couldn't do it at this stage, you can't do part of it, but if we've got, you know, one term on this side, which is that, and one term on that side, then we can raise them both as powers of 4, and that will get rid of log to the base 4. And 4 to the power 1 is just 4. So if we multiply out now with this thing, it gives us what? X squared plus x minus 2 equals 4. Take everything to one side. You've got x squared plus x minus 6 equals 0. Factorize it, you got what? X. It's going to be 3 and 2, and the bigger one's got to be positive to give us plus 1 there. So we've got x equals minus 3 or 2. So remember, when we add, we multiply, and to get rid of a log, you do 4 to the power. But we can only do this stage when we've got one term on this side and one term on that side. This was 2 separate terms on this side, so you couldn't do that then. Okay, right, so that was that one. This last one here, it's log. Generally log's taken as being log to the base 10, but this would work with any base here. Again, what I would do, remember, when you add, same base, so we can get rid of the logs, raising to the power 10 or whatever. I'm presuming it was power base of 10 here, but get rid of the logs from both sides. You've got 2x cubed equals 16, so x cubed is 8, so x would be 2. Okay, so if you have a log, same base on both sides, you can get rid of them, provided it's one term on each side. Okay, there are some questions in today's exercise. At the end, they're like this, but they start off like the first 2 we did, which aren't too difficult. Try and remember these rules of logs, okay? It does help that they are, if you like, the inverse of the rules of indices, okay? But these will be used with today's exercise, and you do get questions using this in higher papers. Have a good day.